Welcome all of you, behalf of the Midas Gen. Thanks for attending the lectures. Myself, Abhishek, from the Midas IT, from the Midas technical team. So, what are the today we were seeing only the modeling of the Midas Gen. So, in the modeling, we will do only the normal geometry, which is 8 by 8 meter geometry, and with a flat slab, and the same flat slab at the all four corners, we will model the L-shaped shear wall, then some of the columns, drop panels, and then we apply the loading. Only the gravity load we will apply, not about the lateral or something. And the same thing we will directly send to the Design Plus. We will see how the L-shaped column we will design by using the Design Plus. Then we will same Midas Gen file we will transfer to the DShop. So how the flat slab drawing will generated by using the DShop program that we will see today. So this is only the small we can say introduction type, or we can say the small thing about the flat slab modeling to design in the by using the Midas products. So Midas Gen, Midas Design Plus, and the DShop. So we are the checking the these are the things. So I will start for the session. First of all, I will start from the Midas Gen, and then after the completion of the Midas Gen, I will what are the doubts you are having, we will discuss, and then based on that, we will again go for the Design Plus, and then again we go for the DShop. So this the step-by-step things we will see. And one more thing, so what are the things we are doing today? I will record these things, and I will upload and send to you the all the links for the record purpose, so that you can save this particular recording, and you can if you are getting time, you can again recheck if something is missed or something you wanted to know more in detail. So these are the things are available. So I will start for the sessions. I will just stop my this one. Okay, now we will start. First, I just open the Midas Gen. Now in the Midas Gen, so what are the things we can do is Midas Gen, it is a kind of the general structure. So you can design the any type of the structure, like your steel structure, RCC structure, composite structure. And we are having the various options to design the particular structure. Even you can model the any type of the shape, and this one also. So these are the some options are available. Today we will see about the flat slab modeling and the design. So for the flat slab modeling, we will do the what we can say the 4 bay of 8 meter in X direction and the Y direction, and then we will generate. So at the generation of these things, we are having the three method. One is the you can use the grid line, otherwise second by point wise, or second third thing is the you can directly import from the AutoCAD DXF. Because in the Midas Gen we are having the import functions, the various we can say Midas Gen like AutoCAD, SAP, STAD, ETAB. So these are the file you can directly import it by using the Midas Gen. And one more thing, we are having the link with the Revit and the Tekla. The direct link is available. So those models also you can directly import it into the Midas Gen. So I will just start for the these things. So first I come to the properties, and I will define some properties. Say property, material property. I just say add. So type of design, I just say concrete. Standard means you need to select the code. I will select the code, say ASTM, that is the American Standard Testing Material. And the database, I just select the 40 grade and apply. So this is for the particularly I can just say for slab I can use, and for wall I will use the 50 grade slab, sorry, vertical elements. I just say okay. Now these two materials are done. Now second, I come to the next box section, say add. First, I will apply, say, solid rectangle, say beam 450 by 900. User, my depth is 900, and my width is 450. So now you can see here H and B, it is mentioned here. It is mentioned about the which are the shape size, and means we can say the symbols, and according to your dimension in the below, the value or the particular image will generate. So you can the program will guide you whether you are inputting the proper value or not. I just say apply. If you say apply, the command will continue. If you say OK, the command will stop. Now I will generate another property. Just say C, say 500 by 500. My H is 500 and this one is 500. So two property we are generated. One is the 450 by 900, which is for the periphery beam, and the internally we will use the 500 by 500 column. Say OK, and come to the thickness, add. So for I just say 200 thickness for the your slab, say 400 for your drop panel, and zero point 0.3, that is the 300 for your shear walls. So these are the three property I have generated. If I close, now I come to the works. Now in the works you can see the grade I have mentioned 40, then 50 grade, then 450 by 900, so 50 by 50 means 500 by 500, and then thickness 200, 400 and 300. I will just save this file. It will ask the file and I just save the webinar and just say flat slab. Okay, now I save this file. So next time onward, program will automatically save because we are having this option, tools, preference, general. Now you can say auto save. So every 10 minutes, 5 minutes, program will automatically save your file. Now I come to the nodes and element and just say create node. Say 00, okay. Now you can see I have created one node. That particular one node, if you want to see, you can see at the coordinate of 0, 0. If I use this option, select single, by using the view select option, select single, and if I select something, now you can see here one node is selected. So basis on the one node, I will generate the other node. I just select this one, right click on the tree menu, or sorry, on the screen, nodes, and I will say translate. Now in the translate, I just say 8 meter 4 times apply. Now here you can see 1, 2, 3, 4, 5, it is generated. So I don't want the last one, I just keep it. Only these 4 nodes. Same way in the y direction we will copy. So x is 0, y is 4, sorry 8, 8, and just say 3 times apply. Now this one is geometry generated. Now this is only the node. By using this particular node, we will generate the so many things. So currently we will not doing anything. We are just generate the node, and with the help of this node, we will start first generating the reference lines. For the generating of the reference line, I just come to this option, nodes and element, and I just say create element. First say general and tapered beam. Grade is 40. My beam is 440 by 900 and click here. We are having this option intersect node and element. By using this intersect nodes and element, the program will automatically divide the element at the joint. So I just select first and I just select last one, first and the last one. Now if I select by using this option view, select single, and if I select here, you can see the program will automatically break the element. You can see no need to break the element. So by using this program, the program will automatically break the element. Now I will copy this X particular beam, right click, say element, and I just say translate. Translate means we are having this option copy or move. I wanted to copy. So I just say in the Y direction, it's 8 and the 3 times apply. Now you can say this one is generated. Similarly, this direction, say 8 X direction, Y is 0 and say apply. Now this one is generated. I will show it into top view. Now this one is generated. Why I am generating these things? Because I will just click on this row and I will copy it into the 1.6 meter because my drop panel size is 3.2 by 3.2 and from the center one side is 1.6 meter and the other side is 1.6 meter. So I will just say here 1.6 one time apply. Say minus 1.6 apply. Same way for this one 2 3 my x is 0 and my y is minus 1.6 apply and this one this one this one I just say plus 1.6 apply. Now this is only the one geometry I did. If I use the of this option hidden, now you can see this is the one my geometry. Now by using this one I will start the my generating the slab and the column and the rest of the things. Now if you see the 3D view, this is only the periphery geometry. I just select these are the things you can import from the AutoCAD DXF also. No need to generate it here. Right now I am generating here because of the showing purpose how the things we can directly generate by using the Midas Gen. So I just select only the nodes 1, 2, 3 which is at the center. So this particular center means it is the column point. So we will select this particular center points and I will show you the 3D view. Now this is the one selected nodes. Now I go to the nodes and element. I just say extrude. Now in the extrude, we are having this option node to line element and we will say grade C50 and my this one is 450 by 900. So instead of that I will say 500 by 500 and my height is minus 4 meter apply. Now you can see my column is generated. But all the edges, like all the 4 edges, we will provide the shear wall. So instead of provide the shear wall, so I just select this one, this one, and this one. I just selected this one and I will delete it because we will provide at the all the corners L-shape shear wall. Okay. So now I will just select this one, 2. Okay, sorry. Okay, now this one is generated. So for the for the generation of the shear wall, what we will do first we generate the slab and then we go for the shear wall. For the generation of the slab, come to the nodes and element and you have to say this option auto mesh. Now in the auto mesh, say line element means you have to select the periphery line. The program will generate the slab internally. Second option is nodes. Nodes means you have to select only the periphery nodes. It will generate the slab internal areas. And the last one is the planar element means is it already slab is available. Now what I will do is I just select the option nodes, say quadrilateral, that is the 4 noded. Then length mesh is 1 meter by 1 meter. My element type is plate. Material means the grade of concrete I will say is 40. Thickness initially I just say 200. I click on this option, this green box, and I select the only the periphery nodes and just say apply. Now the slab is generated. If you see, the slab is generated. But now in this particular slab, whenever your slab is generating, here we are having this option domain. Domain means it is a group of the element and the program will automatically generate the domain. Without this domain, you cannot design the any members. So program will automatically generate this domain. Now in this domain, if you see in the tree menu, these are the domains are generated. Now if you want, you can club also. Like if I select this one, now you can see this is the fourth noded. So same way, I will select this particularly four noded elements. Otherwise you can manually select it and then later on you can just say make it into the one domain, means as a one group. So for the drop panel you need to generate the different group, and for flat slab you need to generate the different group. So that program will automatically identify this is the different thickness and this is the different thickness. I just say right click and just say select. Now you can see all the drop panels are selected basis on this element. Now I just select one domain and click on the screen. Again I select this one, only the rest of the part it is selected, and I just select this domain as a one. Now rest of the domain we can delete because it is not required. Domain it is only the generated. Now if you select the first domain, now this is the first domain, and I select the 400 thickness, which is the drop panel thickness, and drag it to the screen. So before drag it, I will just show you into the 3D view. I just off my beams and I just open the hidden view. Now you can see here all these things are coming into the one thickness. I will select the one this drop panel and I just change the thickness size from the 200 to 400 and just drag it to the screen. Now you can see the program will automatically change. Now entire thing is coming from the center to center. Now I wanted to flush from the top so that my all wrap panel will do it from the top. So just go to the structure and just say structure type. I just click here. I just say align top of the beam for the beam, and this one is for the slab, and click on the convert sulfate into the masses. This is for the mass conversion. So I just say okay. Now you can see if I generate this one, you can see now all the drop panel and entire thing it is set from the top, the proper alignment. So you can check your drop panel and the flat slab thickness. Now I will just say activate all. Now I select the top view, and in the top view what I will do is I just go to the tray menu works and I just say 450 by 900 and just say activate. Now all the elements are activated. By using the select single, I just select this internal part and just go to the nodes and element and I just say element and delete. Okay, use this option nodes and element and delete to delete the element. If you directly use the keyboard button delete, then program will automatically delete all the nodes. Okay, and which are the elements are connected to the nodes, so entire thing will delete it. So don't delete the keyboard, always click the element delete. So okay, now you can see all these particular nodes are there. Now we will select this periphery columns like this one, this line. This is the L-shaped column we will generate. So I just select this particular line. Okay, now you can see this line is selected. Then I go to the nodes and element, I just say extrude, and instead of nodes and line element I just say line to planar element. Always click on the remove so that the existing line will automatically delete it. Then plate, instead of plate you have to say wall. My grade is 50, my thickness is 300, and the membrane and the plate options are available. Membrane means it will take only the in-plane movement, and if you say plate, it will take the in-plane and the out of the plane movement. So you have to always click on the plate option. Wall ID, it is a kind of the the peer label you can say, or the wall numbering. You need to define it. Without that, program will not design the member. And the height, I just say -4, say apply. Now you can see the shear wall is generated. I will open whole structure. Now you can see all the periphery shear wall, internally columns and the rest of the things. So this is our one floor is generated. So by using this various method, we will generate our column as well as the flat slab and the shear wall. So the beautiful features available, that is the auto mesh. So whichever the nodes are there in between of the particular area, the program will automatically take care of these things. Okay, so these are the things are available. Now I come to the next part, loading. For the loading, we need to first define the load cases. So I just come to the loads, say static load case, and I just say here dead load. My type is dead load, add LL, that is the live load, click live load, add. Simultaneously you can define your earthquake loading, wind loading and entire thing. So today I will just inform earthquake X. Say type is my earthquake, add, and earthquake Y, add. So this is only the name. We will define only up to the earthquake loading. The rest of the thing we will not define the wind loading and this thing, because we have generated only the G+4 structure. This is only for the getting the idea about the Midas Gen, the Design Plus and the day shop. Now this one is generated. Now next thing is, first in the static load, structure load masses. First option is self-weight. I just click on the self-weight and I just say dead load, and my self-weight multiplier is -1, so that program will calculate the 100% self-weight in the dead load case. This is the first thing. If I close, now in the tray menu you can see the self-weight, it is coming into the dead load. Now the self-weight is calculated in the dead load case. Second thing is, I just say load to masses. This is means mass source, how much the percentage you want to calculate for the seismic weight. So I just say my dead load is 100% and my live load is 0.25%. Okay. Now you can see here in the tree menu, if something is not appear in the tree menu, so there is some problem in the definition. So you have to know it to go again and you have to do. Second thing, whenever you are defining something, you have to always check the message window, which is into the normal is in the below window, in the message window. Without that, if something is not appear or something it is not there, then you can identify there is some problem. So this is the one option you can identify whether the what are the things you are defining, it is properly defined or not. Now I select, go to this option, plate, by using the element option, say plate. I just select the plate element. What I will do is I directly apply the loading into the slab, and so throughout I'm using the same loading. I will not change the loading pattern. Otherwise you can select the each and every panel and you can define the loading. I just select this one. I just say pressure load and just say pressure load, assign the pressure load. You can make the group also, otherwise you can directly define the loading by each and every case. I just say dead load, replace, and I just say minus, say 3, because I'm just putting the higher side value, say 3, apply, and the previous selection I just say live load, say 3, same, apply. Now I just close it. In the tree menu you can see the pressure load in the dead load display. Now you can see this is the pressure load for the dead load, and if you right click here in the tree menu for the live load and display, now you can see this is the live load. I can right click and display, so it is gone. So in this way you can check your pressure load and the live loads. So these are the loadings are done into the one floor. Now what I will do is I will copy into the another 2 or 3 levels, and then we will fix the bottoms support condition, and then we will apply the lateral loadings. So I just select all members, just go to the view, select select all. Now entire thing is selected. Go to the structure and you have to say control data and say building generation. So which are the elements you generated or you are selected, the based on that it will generate the structure. So I just say number of copy, say 3, my height, it's a 4 meter, or you can define anything. I just say add and just say apply. At the time of applying this one, we are having this option copy node attribute, elements attribute, or the building attributes. If I click here, you can see the along with the your geometry, the program will copy the your end releases, beam loading, and entire thing, even the pressure load also. If you do not want, you can off this option. Otherwise, you can continue with this one. Now, if you see here, right click, say display. Now you can see everywhere you can see the value. I just show you the top front view. Now you can see everywhere load is applied. So what are the things we are doing? So everything is there. Now I will define the first bottom nodes. Just come to the view, select by plane, and I will select the XY plane. In the XY plane, I just select the bottom node so that program will automatically select all the nodings. So now all the node are selected. I just go to the boundary, say define support, replace, say D all, R all, and apply. Close. So now you can see here all the support conditions are defined. This is the support condition. Now we will come to the next part, which is about the lateral loading. So for the lateral loading, the three things you have to keep in mind. First is structure type. Whether you selected this option, convert sulfate into the masses or not. If it is not selected, then it will show the wrong result. So you have to click always on this option. Then control data, you have to generate the story. Okay, I just say story. Then program will, you have to click on the auto generate story data. Say first floor, second, third, fourth, and the roof. Based on the height, the program will automatically take care. The accidental eccentricity 5% of plant dimension, and for the wind it is 15%. Say OK. Now you can see the do not consider, it is automatically coming. Do not consider means it is the semi-rigid. So program will automatically consider the semi-rigid diaphragm if you model the flat slab. And I just say close. Now this one story is generated, and the third thing is in the load you have to check the load to masses, whether you define the load to mass or not. Now this one is also defined, so now we can go for the lateral loading. If these are the things are not defined, then you can face the issues or you can face some error in the lateral loading. So I just come to the seismic loads, say add, say earthquake X, seismic load code. Instead of I can select the ASC 710 also, I can select the UBC. I will just select the UBC. Say soil type is SB, seismic zone 2B, and my structural parameter depending upon the UBC. If I select the period calculator, the program will automatically ask the formula, which formula you want. I just click the OK, same formula, and then my X is 1, Y is 0. And the accidental eccentricity, whether you wanted to consider the positive X, positive Y, negative Y. If you consider otherwise, right now we are do not considering, so we have to just say none and click on the seismic load profile. Now in the seismic load profile, okay, now in the seismic load profile you can see the profile. So in the profile, sorry I mentioned the R value wrong. I just say 4.5 and 4.5. Okay, I just click on the seismic load profile. Now you can see the profile, seismic story force, story shear, and overturning movement. Now in this floor, in the particular this thing, each and every floor you can get the seismic weight, seismic force, the your story force, and the story shear also. So without run analysis you can get these values and you can identify whether it is coming fine or not. Now next thing is I just click on the seismic load and calculation sheet. The program will tell you this is the value Z, I, and the soil type. So based on that UBC 97 table 16Q and R CACV value it is calculated. This is the seismic weight, and this is the base shear value. This is the seismic coefficient. If I multiply these two value, seismic weight and the seismic coefficient, you can get the base shear value. So these are the options are available, and I just closed it, close, and I just say apply. Now this is for the x direction. I just keep the same y. X is value is 0 and y is value is 1. The rest of the data are same, and I just say OK. Close. Now in this structure, my static loads, pressure loadings, entire thing it is defined. Now my geometry and the entire building is completed. If you want to define the other loadings, so we have the dynamic load, temperature load, construction stage, moving load, various options are available. By using this option, you can define the other type of the loading. Now what we will do, we will not define the other things. We will go for the next part about the designing, because I wanted to show you how the flat slab design we will do it into the Midas Gen, and then same thing about the Design Plus and this one. Now come to the analysis. I just say perform analysis. So it will take the few seconds to run the analysis. Now you can see 2.34 seconds is required to run the analysis of this particular structure. Then I come to the results. First is the load combination, because for the results we require the load combination. So we will select the first load combination and go to the concrete structure, concrete design, say auto generation, ACI 31811. And if you want, you can consider the orthogonal effect. If you want, you can consider the special seismic load effect also. Means whether you wanted to consider the omega factor, overstrength factor. So these are the options are available. I just say okay. Now this one is generated. My serviceability as well as the strength combination, it is generated by the program. Okay. Now we will go for the other things. I just closed it. I just open the any one floor first. Yeah. First, reactions. You can check the reactions. I will show the other things like the forces. Sorry, deforms. I just say displacement contour. And in this, I just select the any one combination, the CLCB2, say DZ, say legend, deform shape, and apply. Now you can see the value. I just changed the unit to the mm, and my values are coming into these values in the scientific. I just click on the next to the legend, this dot dot box, and I will say fixed value. Okay. Now you can see that my maximum is the all the values are coming negative, and the maximum is 12.92. Okay, so each and every panel you can get the 12.92 values. These are the column near the column area. If I click here, you can see the deform shape also, because I click on the deform shape. If you want animation, say apply, click at the center. Now you can see the animation. So this is about the animation. So in this way you can find out the animations. Then I will come to the next option, forces, say beam diagram. Select the any one combinations, my value, all, apply. Now you can see the moment values. Nearby column it is coming the negative values, and in the between it will come the positive value. Now you can see here the proper diagram. So each and every corner you can get the values. Now I select the forces and I just say plate force and movement. Now in the plate force and movement, I just say any combinations, say moment XX, and if you say UCS, by UCS axis, I just apply. Now you can see this is the moment in axis. If you click on the value, you can see the values. If you click on the legend, you can see the legend, and even if MYY, you can see this MYY. So these are the some options are available to check the values and the entire thing: MXX, MYY, MXY, forces, maximum movement, minimum movement. So this is regarding the results. You can get it by using the forces option. In the results, we are having these forces. We are having the truss forces, beam forces, plate cutting line diagram, wall forces, wall diagram. So these are the options are available. If it is saying the forces, means it is showing the contour. If it is showing the diagram, so it will show the direct bending moment and this type of the diagram. So these are the two options it is mentioned in the our menus. And for the other results, I just come to the result table. Story, so we are having this option: story drift, story displacement, story shear for response spectrum, story shear for time history, story mode shape, eccentricity, story shear force ratio, torsional amplification factor, stability coefficient, overturning moment, story axial force, torsional irregularity check, soft story check, weak story check. So these are some options are available to check for the results. Now I will come to the next part about the designing. Before going for the designing, I wanted to tell you the one thing. I just open the entire structure and I just open the wall and I just say activate. I mean this particular wall, I just go to the display, go to the element and I just say wall ID. Say okay. Now you can see everywhere my wall IDs are same. I wanted to define the different wall ID. So I just unlock the model because otherwise program will not design. So go to the nodes and element and I just say change parameter, wall ID, say 1. For this one, if I'm considering into the top view, so it will consider the all the elements, this particular, say 1, okay, yes, 2, 3. Automatically program will change the numbering because we are saying the auto increment. So only the next numbering it will take. We are having the another options also like fixed value or last number plus 1. So if you miss last number, the program will automatically take care of next numbering. Now this one is done, entire thing. Again I run the model so that we can go for the result for the design part. Now I come to the design. First is general design. We are having first option, definition of the frame. I just click here and I just say auto calculate effective length factor, so that program will automatically calculate the effective length factor. General design parameter, we are having this option member assignment. Now in this member assignment, program will automatically take care. How means what is the importance of these things? See first, if I double click here, now you can see the program will automatically consider a single element for the design. Now you can see the column to column, it is considered the single element. Otherwise, it is break into the number of part because of the join. But if you want to design it, the program will automatically take care. Now you can see this is the single element. So from this point to this point, program will consider the total length for the calculation of this particular beam. So this is the one more additional options are available in the Midas Gen. Then I come to the first option, RC design, say design code. First is ACI 31811. Along that we are having this option, apply the special provision for seismic design, say special movement, overturning, ordinary movement or intermediate movement. So these are the three options are available. Even for the shear wall calculation also, whether the boundary condition, how you want to calculate. So these are the options are available. Whether you consider the secondary beam, cantilever beam and the torsion design. So these are the some options are available. If you click on this option, so you need to first design the beam, then you need to go to the column and then these are the parts. You cannot directly design the columns. Then modify concrete material. I just click here, my grade. Now I have to define the rebar. So generally I use the rebar as a BS so that I can define the 460 and 460 apply. Same way grade for the other these things, because up to this we have not defined about the rebar grade. So we have to just define the rebar grade. If you want, you can define your own values also. Just click here as a none and give the name, and the program will automatically take care of FY and FYS values. So this option is also available. Then we come to the next part, RC design, say design criteria of rebar. So because according to this, the program will tell you the number of bars. So for the beam, I will just say 12 mm, 16 mm and 12 mm. Okay. And my stirrups are 8 mm and my cover say 0.04, 04. Column design, say rebar. I will say 16 mm and 20 mm bar is okay. So program will tell you the 16 mm or 20 mm bar based on this particular the numbering diameter. So program will tell you the number of bars. Even the program will tell you the AST also. If you if you want to take the same the rebar number of bars to be calculated by the program, so you need to properly define the diameters. And for the shear wall, I will just say 15, 12 and 16. Horizontal bars 8 mm, say vertical 12, say 0.04, 04, say okay. Now I come to the design. Another options, we are having this option, modify beam, column and the brace and the wall, so that you can define your own rebar and you can check also. These two options are available. You can design the member and you can check also depending upon your own reinforcement. So I just say concrete code and just say beam design. So it will take the few seconds to design the members depending upon the your number of load combinations and the element. Now you can see we have designed the whole structure, but it is showing only the one because you need to click on the member. Now you can see entire thing. I just click here, you can see 8 or 8 number of bars at 12 mm, then 2 bars of 12 mm, then 8 bar of 12 mm. So this is the first load combination, negative moment, then load combination, the top AST. My unit is in meter. If you change to the mm, you can see the mm square. My rebar value, positive moment, load combination, bottom steel, rebar value, VU value, load combination, vertical ASV and the stirrups. If I click here and if I say graphics, now in the graphically also you can identify how the program is calculating the value. So first is the section diagram, then second is the start, mid, end, the bending moment capacity and the shear capacity. Now how it is calculated? So you can just click on the detail. Now in the detail you can find out all the formulas. So if you go down, you can see how the maximum it is calculated, minimum it is calculated, what is the my criteria, how it is calculated. If I go down here, the program will tell you about the shear also, how the VU is calculated. It is the VC is equal to 2 square root of FC BWT, even 5 value, how the 5 value is calculated, 5 VC value is calculated. So entire thing it is mentioned here. And if you want to know this result for which beam, then you need to click on the connect model view and then click on these options. Then program will tell you this is for the which reasons. Okay, now this one is for this one, this one is for this one, this one is for this one. So basis on that the program will tell you. So these are the options are available. Another RC design, say concrete code, say column design. We can design the column and same way we can check the results like in the graphical format as well as in the text format. In the particularly column or vertical design, I just click here, just say graphically. Now here you can see number of bars, this one say 1% steel, 8 or 8 number of bars at a 20 mm diameter. So PU value, MCY, MCZ, MC values, then axial force movement, PM interaction diagram, shear force at the end and at the middle. So these are the values you can get. And this is the PMM interaction diagram, which is the 2D form. If you want the 3D, you can click on the draw PM curve. Now here you can get the draw PM curve 3D values. Then if you say detail, then in the detail you can get all the values like the how the slenderness effect it is considered. You can see here radius of gyration, this unbraced length, effect to length factor, whether the slender or not slender. So according to this method you can identify how the program is calculating the value, and if the values are coming, then according to the which basis the values are coming. So you can modify your parameter. Just closed it. And same way for the RC design, concrete code, say wall design. What are the we check for the wall? The same thing for the column. The same thing is available for here. I just click here, say graphic. Now here you can get this is the one bar, say value. So vertically 16 at 150. This is required, and horizontal 8 or of 127 it is required. So these are the options are available. The program will automatically tell you. Even it will tell the detail also. This one is okay for the column and the wall and this one. Now I come to about the shear slabs. Just come to the mesh design. So this mesh design option, it is only for the plate element design. So I just use the design criteria of rebar. So here you can define the basic rebar mesh. So I will just say here 12 mm, 12 mm, 12 mm and the 12 mm, which is 200. Okay, then the rebar, the 10 mm and the 12 mm, it is okay for me to find out. Even the 8 mm is also okay. My spacing, I will use the, I don't use this one, 100, 200, 300 and the 400 spacing. And my cover is 40 mm for the slab up to the center of rebar. You can see in this particular box in this image it is mentioned about the DT, that is the top cover, DB is the bottom cover. Same as the mat design, this option is available. I just say okay, yes. Now this is the total mesh I have defined. Now I come to the mesh design. I just define the serviceability parameter also, like L by 250 or which one. So according to that it will check the deflection. I just come to the mesh design and I just say slab flexural design. In the flexural design, it is asking whether the element wise or the average nodal wise. So these two methods are available. Element wise means it will take the maximum value. Average nodal wise means it will take the average of the four node values. Top, bottom or both means according to the which method you wanted to calculate the values. Whether the for both the direction you want or you want only in the top location or the bottom location. Direction 1 is the X direction, direction 2 is the Y direction. I just say value. I want to know about the AS required mm square per meter. If I say apply, the basis on the your this one, the number of panels, the program will take the time for the designing the element. Now you can see this value. I just change the unit to the mm, and now I come to this one. Here you can see all the values. So I just open the any one floor, so it will guide you. Now you can see this is the area of steel in mm square per meter. If you say rebar and if I say apply, so now you can see all the values. Okay, these are the rebar. So I just say top direction 1 X apply. Now this is the value. So here the program will tell you the two value. One is the 12 at 200 means it is the sufficient here, and the second one is the 12 at 200 comma 8 at 200 means the 12 at 200 is the basic mesh and the second value is the additional rebar is required. So this one is the program will tell you whether the additional bar is required or not. Here also you can find out 12 at 200, 12 at 100, 12 at 100, 12 at 100, 12 at 100. So basis on that you need to tell the program the 12 at 100 is required. Second, bottom apply. Now you can see how the bottom bars are required. So each and every places you can get the bottom rebar values. So 12 at 200 it is not sufficient. Here we need to change it to the 12 at 150 or the 200. So at the bottom of the drop panel also it will fulfill. So best way, in this way we can check the results for the top, bottom, direction 1 and direction 2. Okay, so in the contour form it will show the values. So what I will do is I just click all, say apply all. I will design the entire structure. Both all apply. I just design the members so that the program will take care of all this. Okay, and now we are designing entire structure, and what we will do is we are saying the update rebar. Update rebar means what happened? The program will automatically take care of rebar basis on the designing so that we can perform the long-term deflection value. Otherwise, we will not perform because without the reinforcement data, the program will not calculate the this one. I just say update rebar and closed. Now in this tree menu, you can see for the top, bottom, direction 1, direction 2, the program will tell you about the reinforcement data. Now I come to the next part, say mesh design, slab shear checking. I just open the one floor. At the time of the punching shear, program will take care of the reinforcement data. I just say value, apply. Now here, if the values are coming more than one, so it is fail in the punching shear. If I select this particular element, okay, and if I say design result, now in the design result I can get the value, how the B0 perimeter is calculated, how the beta values, phi value, VC value, VU value, whether there's no need of reinforcement. So program will tell you, okay, it is not required. If it is required, then program will tell you about the AST also. Now the detailing you have to do it, how you wanted to do the detailing. But these are the things are available in this one. Even you can check the one-way shear check also. This option is also available. Now I come to the another option, mesh design, just say slab serviceability checking. I just say uncrack and say value and apply. If you do not define the reinforcement data, the program will not calculate the long-term values. So you need to click on this option, say crack, uncrack. Right now it's uncrack. Yeah, you can see the values. It's minus 9.3 and it's a 0.39. It is for the all combination, means for the worst combination it is checking. Now if I use the creep value, means the crack value, and if I say apply, the instead of 9.3, you can see how the values are drastically increased because of the long-term crack deflection. So this is the option is available. So I will just show you. Yeah. Now you can see 37.20. So this is the long-term crack deflection. The previously it is 9 point something and now it is 37. So almost the 3 to 3.5 times it is increasing. So this is the way you can calculate the check the values by using the Midas program. So this is regarding the design and the entire things in the Midas Gen. So anybody is having the okay, so we will come to the this one. Now I just wanted to know whether you wanted to know more about the Midas Gen, so that you can ask me. Just type in the chat box or question box. So I will tell you the what are the things, and so that otherwise we will start for the next part about the Design Plus. Because in the Design Plus I wanted to show you how the L shape or the irregular shape of the column designed by using the Midas Design Plus as well as the footing design. Okay, Mr. Abhilash sir is asking about the property modifier. So we are having this option in the properties scale factor, says section stiffness scale factor, plate wall stiffness scale factor, and plate stiffness. If I click here, now you can see for the axial shear and the bending, you can define the property modifier. So this option is available to define the property modifiers. Okay, so he's asking about why the results of the right bottom corner of the slab is different from this other corner, although the floor is symmetrical. Okay, I will just check. Just open the one slab. It is not happening because it is all the geometries are same, so it should show the same values. So you wanted to check the torsion is considered for the beam design. Yes, torsion is considered by the design, but only the thing is at the time of the designing, in the RC designing, you need to click on the design code and you have to say torsion design. If you click the torsion design, then program will design. And about this one, I just open the one result. Say refresh, say plate forces, say dead load. Instead of dead load, I just say combination, movement, value, say legend, not apply. Now you can see only this corner, four corners having the different view, but otherwise rest of the things are common, same way. Even if I change to the MXX to MYY, I can see there is a nominal difference, not the too much difference, maybe some 1, 2 or 3 values, but the rest of the values are coming same. See the top and the bottom corner, both the corners are looking the same. Sorry, sir. Okay, the one more question from the engineer Madrake is asking about the is it possible to get the reinforcement output on the strip basis? Sorry, sir. Currently, we don't have the strip based method. It is the finite element based method. But we are launching the maybe on the next month we will launch the strip based method in the Midas Gen, so that you can directly draw the strip and you can directly design the element. So same as what you are doing in the safe. So same thing means it is the more than that actually we are launching in the next version. Currently crack width check for the slab, it is available basis on the Euro code. You can do if you change the code, I will just show you. Say design, instead of this one, if I say Euro code and if I use this slab serviceability checking, here we are having this option crack point, contours, crack control, crack width. So entire thing you can check by using the Euro code. For the ACI code in the next version it is coming, because in the next version we are launching the strip base as well as the crack width for the slab. So these two options are implemented into the next versions. It is already the programming and entire thing is done, and even the checking it's also done. Now only the thing is the releasing. So there might be they will release in the next month, so that these two things are already been covered according to the ACI code. Sorry, sir, for long-term deflection, you can check in the Design Plus, not in the Midas Gen. In the Design Plus, we are having this option. You can define the long-term, the factor value L by 250 or L by 350, means whatever the factor you want. The ratio you can define, and you can define the sustain load and the creep values. So that program will take care of and calculate the long-term and short-term deflection values. For the deformation, you can go to this option. I just open result, say deformation, I just say displacement contour or the deform shape. If I say displacement contour, so I can check the displacement. If I say deform shape, you can check the deform shape. I will just open the 3D view, say deform shape, CLCB1, DZ, animation, apply, say click. Now you can see the animation of the deform shape. So these are the animations, you can get it. If I use the earthquake X, apply, you can see this is for the DX. So these options are available for the checking the results, deformations, and this one. Any other things you want to say into the Midas Gen? Thank you so much, sir. Okay, if the punching shear is it is failed, the program will tell you about the ratio. If you see mesh design, say slab shear checking, say value, apply. If you check this value, the values, if the values are coming more than one, means it is a fail in the punching, because the capacity and the ratio it is coming, it is a not the less than that. So the program will tell you the values are coming more, so it is a fail. So if it is a fail, if you check the result data, the program will tell you about the AST, how much the AST is required. So we have the two options. One is increase the depth, otherwise you can provide the shear key. So it's depending upon the engineer, the what they want to do. So program will tell you the both the thing. One is the value, which is the more than one. Now you can see here. Yeah. Now here, this is the one value it is checking. If I consider here, say design result. Yeah. Now here you can see in the below, calculating the outermost perimeter of the shear reinforcement, and it will show about the all the values, how much the AST is required. You can see not acceptable, so it is not acceptable, need the vertical reinforcement. How much the steels are required, it is mentioned about here, 8215.1057 mm square per meter. Actually, the thick slab and thin slab, actually we are having this option at the time of the nodes and element. Say create element, say I just say plate. So we are having this option thick and thin. So basis on these two, it is considering the shear deformation. If you say thick, then it will consider the shear deformation. If you say thin, then it will not consider the shear deformation. It is only the changing with the shear deformation. The rest of the in plane, out of the plane movements and entire thing will take care if you consider the plate element. Any other things? Okay, even after the analysis, if you check the analysis results, I just unlock the model, I just run it. Once you run the analysis, the program will tell you at the message window, your Midas job is successfully completed. If any error is there, the below of this message window, the job is successfully completed, it will show the some error, and it will show the node numbering in the which node number there is an error, whether it is singular error or whether it is the other error. So if something error is there, you need to directly go to this box and just type the node number and enter. The program will highlight the node, and you can check whether the connectivity problem or any other problems. Yes, you can change the any this one reinforcement data. You can see now if I double click from the tree menu, it will show in this area it is generate. It's required that 12 at 200 and 12 at 300. So instead of this one, you can just modify say property, and you can change the data. So instead of that 12 at 300, you can change the data. Otherwise, you can select your own element and you can apply your own data. This is for the slab. And for the beam and the column, in the RC design, we are having this option: beam, column, brace, shear bar. You can define your own rebar according to your own method, and then you can design it. Means you can check whether it is passing or not, because you are defining your own rebar, so you need to check. Okay. So we will start for the next part about the designing of our elements. So that about the design plus and the D shop, because it's taking the not taking the too much timing. But I wanted to show you about how the things are there. Does the program give the length of the additional raft? No, no. The program will give you only the reaction, say result, reaction, and the soil pressure diagram. So basis on the soil pressure diagram, you need to identify whether it is in the less than SBC or more than the SBC. So basis on that, you need to modify the your values. So this is the way we can design our element by using the Midas Gen. Okay, so now I come to about the design plus. Generally, so we will start for the design. If you have any doubt or something, you can mail us on the tech support at the rate midasIT.com so that we will discuss the more thing. And otherwise, means in between also because of the lack of timing, we are I'm just going the so fastly because I wanted to show about the design plus and the D shop also. Okay, so first after the run analysis, after the designing the element, come to the Midas Design Plus. Now this is the Design Plus. Design Plus means it is the kind of the individual member design. If you know the forces, you can put your own forces and you can check. Otherwise, you can link with the Midas Gen and you can import all the forces by using the your worst combinations in the midation so that no need to import the values, no need to input the values, and the error of chances means the inputting the error will minimize. So these are the things are available by using the design plus. Now what I will do, I just say file and new project. Now in that one project, what I will show, see here, the slab. What are the things you can design by using the Midas Design Plus? Slab, like one-way, two-way slab you can design. Only you need to define the X and the Y dimension, thickness, initial thickness, and the end condition and the loading. Your gravity loading. The program will automatically calculate the factor and the entire thing. Even for the beam, column, regular column, irregular column, shear wall, again the rectangular and the irregular, footing, individual footing, combined footing, and the pile cap you can design. Basement wall, you can any height of the basement wall, double height, triple height, for a basement wall you can design. Even you can design the cantilever retaining wall like L shape and the T shape, buttress, staircase, corbel and bracket. So these are the things you can design. Even you can design the like beam, column, shear walls in the Midagen also. But if you use the design plus, in the design plus, if you want to modify some rebar data, if you want to modify some the forces, you can easily modify it and you can directly take the report as well as the drawing also. So that is the use of the design Midas Design Plus. Similarly, for the steel structure, we are having the beam plus column, base plate, bolt connection, crane girder, purling grid, web opening, and the staircase. So generally these type of the things we use the manual calculations or else Excel sheet for generator of these things. But we are having one tool. So by using of these things, you can minimize your timing and you can get the proper report also, drawing, quantity, entire thing by using the Design Plus. So I will show you for the first is the column. For the column first, I will do one thing. I just change the code ACI 31811. Instead of that, I will say ACI 31811M. M for the matrix unit. Then rebar code ASTM. If you say ASTM, it will show the value into the keep inch and feet. So instead of that, I will just say BS. And we are having the range also like a beam. I just say from the 12 to 32 in column. It's a kind of the say 16, say 12 to 32. So this is only the range. The program will calculate the diameter of the bar in the particular range. So what are the bar you are defining? Even we are having the option preference. If some members are failing, if you say increment, the program will automatically increase the size and tell you the final size. So this option is also available in the Design Plus. Second is this one, Midas link, this red icon. Now in this icon, I just click here. Now program will ask me if the gen file it is open or not. So now the same link, I just click it. So you have to always open the Midas Gen and the Design Plus to link with each other. Now once you link, now it will turn to the green color. Now I will just say beam. So import functions we can work. Now we can import from the your this one. But I will just use first column. Just say column. Now I come to the Midas Gen. So I just select the one member. I just select this one. Now in this selected one member, you can see 2773. This is the element numbering. I come to the Design Plus. say 2773. If I come to the option, we are having this option link by member. So each and individual member you can get the results. And these are the options are available like Gen. By Gen means according to the program will directly take care of which is the design forces. If you want to take the minimum maximum forces you can take, or if you want to select it means the PU, MX, only the PU you want. You don't want the MZ or shear value. You want only the PU and MX. So you can only input this value. So these options are available. Then keep the section and bar data so that according to the Midas Gen program will automatically take care of rebar data as well as the same size also. Then I will say import. Okay. Now in the tray menu, I just click this one. You can see C4 500 by 500. This is the beam. Now this is the my axial force, shear, then my shear forces, coefficient factor if you want to change it, and the load combinations. If you want, you can define the load combinations. Otherwise, program will automatically take care of this particular forces as per the Midas Gen. If I say check, so depending upon this combination or this one, the program will check the value. If I say check, now you can see it is passing. Okay, even we are having the tie bars, apply to the shear check, apply the special provision. So this one you can do. Even the you can design the reinforcement minimum and maximum reinforcement you can set. Now I come to the next box. If I say report and say detail, now in the detail report, the program will tell you into the Word document. So which are the formulas are available, whatever the data it is considered. So entire thing, no need to manually generate this report and no need to type anything. It will take a little bit time because it is directly connected to the your Microsoft Word document, and it will directly open the Microsoft Word, and in the Microsoft Word it is mentioned about the all step-by-step formulas how the program is calculate the value or design the member. So for each and every element it is designing. And the same way for each and every element you can design the member and you can take the results. Here you can see. Yeah, so this is the member, Ly, Lx values, entire thing. This is the column, forces, factor, rebar. Check the slenderness ratio with a formula, slenderness ratio. Check the magnified moment at the calculate the magnified moment at direction X, direction Y, major axis, minor axis, even the minimum moment eccentricity, and the column design parameter and this one. Okay, what you are asking? Okay. Does the program give the length of, okay, the is circular column is included? Yes, sir. If you click here circular, you can design the circular column. You can manually, you can do it here and you can change it, or else you can import it from the design Midas Gen also, so that it will take the all these values and entire thing. Now I come to the next part about the drawing. I just say create. So basis on this one, the program will create the drawing. So this is the drawing is generated. So how the reinforcement data we will provide, according to that it will generate the drawing. And this particular drawing, if you say save as, so it will save into the DWG format. No need to do anything. The program will automatically save it. If I come to the quantity, if I say create, the program will create the quantity. This is the sum size, layer, concrete, meter cube values, formwork value in the meter square, and the total kilonewton steel. So these options are available. In the Midas Gen, it is not generated the shop drawing, but in the D shop it is generated. So I will show the D shop also once I completed the Design Plus. So I will show the how the shop drawing will generated by using the D shop. So this is for the Gen. Now I come to the file and about the shear wall combine shear wall, say add. I just click here, combine shear wall, click here. And now I just select the L-shaped shear wall. I just select this one and come to this one, Design Plus, all the forces, import. Okay. Now in the shear wall, you can see this one is the top and the bottom level. Means at the both the level it will check at the bottom level and the top level. So that basis on that, which is the maximum you can take. If you come to the next box, section 2, this is about the section arrangement. If you come to the section 3, this is for the load combination. You can see program will take care of all the combination and input all the forces. If I say check, it is checking. Now it is failing. You can say it is fail as a combine effect. Now I come to the member list. I can check. I can just say drawing, create. Now here you can see this type of the drawing it is generated. So P12 at this is the vertical, this is the horizontal. If it is fail, then if it is fail, if I come to the members, now these members are failing. So what I will do is in the section 1, I can change the rebar data. So these options are available. I can change my width and entire thing in the rebar data, so that you can just say 12 mm. Instead of that, I just say this one 200, 127. It is okay. Modify this one, say 200. Modify. I just say check. Now you can see. So in this way, you need to check whether it is a passing or not. You have to increase the rebar data, and now this is the combine effect. Okay, Mr. Sudhir Kumar sir is asking one question, whether we can import the slab forces, properties and rebar from the Midas Gen to the Design Plus. No sir, in the Midas Design Plus it is for the membrane slab, like a one-way or two-way slab design, but you can directly export to the D shop. So that I will show you into the D shop. Okay, so in this way you can design your member for the shear wall and this one. Even one more option is available, like a footing. I just click on the footing. Now in the footing, I will just select the one node. I just select the one node. Now one node 73. If I come to the Design Plus 73, import. Okay. Now all data will import in the footing. All the combinations wise, all those things are coming. If I say design, program will design and tell whether the soil bearing capacity it is this one. I just increase to the 250. Now design, now you can say according to this one it is passing. Okay, my size is 3 meter by 3 meter, it is passing. If you want change, you can change it. Even one more option, isolated pile. You can design the isolated pile also, and you can design the line wall also. So these options are available. If I come to the drawing, if I say create, it will create this type of the drawing. So this is the LY LX dimension, this is the elevation, and this is the one column footing. LX is 3 meter, LY 3 meter. Say column size. This one is the rebar data and the soil capacity. Entire thing it is mentioned. The thickness is 700 is required. So based on that, you can at least get an idea about the individual footing, combined footing, and the pile cap for the rectangular, not the irregular. For the irregular, you can model it into the Midas Gen itself, and then you can design. So this is regarding the Design Plus. Even the base plate, bolt connection, various options are available. The most important is the link between the Midas Gen and the Design Plus. And the second thing is you need to always check the what are the values are inputs are available. So basis on the input you can do. Weld connection, I will just show you into this. Yeah, for the steel beam plus column, base plate, bolt connection, crane girder, purling grid, web opening, and the staircase. These are the things are available. So, what are the things you wanted to do it? So these are the things. Still, we are in the processing actually, because it's still in the one by one so many options are implementing into the Design Plus, but it is a kind of the Excel sheet. You need to manually input it and you can directly get the value. So weld connection is not available, only the bolt connection and the base plate and beam plus column and the crane girders are available. And the Mr. Sir is asking about the very about the for the bridge. Yes, sir, we will do it for the bridge also and for the geotechnical also. We are planning to do the same kind of the one webinar just for the introductory purpose or for the awareness of our about the some of the features. Mr. Abhilash is asking about the composite column. Yes, sir, composite column. This is the composite beam that is available in the Design Plus, and if you do it in the Midas Gen itself, so we are having this option in the properties, section properties, add SRC. Now here you can design so this type of the memos. You can just say here, say periphery of concrete, inbuilt of steel sections or various options. You can import this data and you can design it in the Midas Gen itself. So these are the options are available in the Midas Gen itself. Now I come to about the another. It's about the Design Plus. If you anybody is ask, if anybody want to know more about the Design Plus, so that I will tell you about the other things. Around the column means we are having this option. Sorry, Mr. Abhilash is asking about how about the adding the additional steel plate around the concrete column. See, generally in the properties we are having this option, say SRC, and this one, say SRC box, periphery steel box and inbuilt of the concrete. So if you use this option, then you can use it. So then you can design and then you can check. So this option is available. If you wanted to know about the other than the box, then we are having these options like circular. Circular one is available, even the circular with box, even the SRC pipe, the periphery pipe and inbuilt of the concrete. This option is available. Otherwise, if any irregular options, then sorry, for the strengthening purpose, right now this option is not available in the Midas Gen. Strengthening of beam is available in our Midas set, but that is the outdated software now because it is according to the DS it is available. But currently we have not implemented about the strengthening option. So strengthening you cannot do it in the Design Plus and even in the Midas Gen also. Okay. Any other things in the Design Plus? Yeah, curve slab you can model in the Midas Gen itself because in the nodes and element we are having this option. Create a line on element on a curve, so you can directly create the line on a curve, and that by using the line method you can directly generate the slab, curvature slab, and you can design also. Okay, so I think so we will start for the D shop because D shop those so many questions are related to the shop drawings also. So I will show you the little bit about the D shop. I'm taking too fastly because it's almost the 1 o'clock. So within 15 minutes I try to finish it. So first, once you design the entire thing, once you did the your rebar and entire thing, then you have to come to the file and you have to say export to Midas drawing file. Okay, this is the Midas drawing file. This is for only for the generation of the drawing. So whatever the things you are designing in the Midas Gen, so basis on this design, it will generate the drawing. If you define the rebar also here in the Midas Gen, so basis on the rebar also, it will automatically transfer into the D shop. So file is completed. I just use the D shop, say file, new project, file, import Midas Gen. I click here, say flat slab. According to the ACI 318 non-seismic, beam, column, brace, wall by member wise, it will take all this Midas Gen. Just say OK. Okay, I just again import it. I will directly open the file. Yeah, so it will generate this particular drawing. Now in this particular, this one you can see all the things are automatically coming from the your this one. Now the beam and entire thing, it is coming from the this one. Now what I will do is I will just go to this option. I just click the fourth floor. Now from this one you can identify this is the one particular layout. So one layout also you can generate. I just click here. I just say save. You can save into the DWG format. Okay, if you double click on the any elements like the beam column, it will show the rebar. Now this rebar you can modify according to your own detailing method. Even for the beam also you can modify. Just double click here. This is for the beam. Now you can modify for the beam. Now I come to this one. First, define design code. I can define the code. Even I can define the cover also. So various covers are available. You can see the concrete cover and this one. So basis on this cover, program will calculate the number of bars. Sorry, the total length of the bar and the quantities. So because in this program you can get the quantity. So most important is the cover and this one. For the columns, for wall, steel connection. So these are the options are available. Grid line, you can define the grid line. Splice method also you can define how the splicings you want, 100%, 50% lapping, or according to the which method. So I just click this method. Now auto generate, I just click the auto grouping of member. Always you have to generate the grouping. Without the grouping, program will not generate the drawing. For the wall also we will generate. Now if I come to about the slab, I just say define additional rebar. Now in this particular slab, the program will ask you which type of the floor you wanted to design. I just generate the third floor, and here it is showing about the rebars also. Now these are the areas the rebars are required. This is for the top, bottom, top and the bottom, X direction, Y direction. I just click this one. Wherever the additional rebars are required, I will generate the one rectangular box. I just click on this particular rectangular box. So this is the my one box. Now this area I wanted to provide the rebar. So we need to only generate the rectangular area wherever we require the additional rebar, and the rest of the area no need to generate it because the program will automatically take care because the auto mesh option is available. It will take the little bit timing because in the both the direction as well as top and the bottom location you need to do these things. So basis on this, the program will provide the drawing for the flat slab also. And there is some other options are also available for the generation of the flat slab drawing, whether you want to see the total length of the bar, whether you want to see the additional bar. So means various options are available. I will show you how the things are available. This is for direction 1, bottom direction. Only for the additional area you need to generate the this particular area. Otherwise you can generate the irregular also, you can generate in this way also. If it is provide the rectangular, then it is the good. So this is only the kind of the we can say the strip type, so that only those area it will take the max value, it will not take the less value. So this is only the area. Over there the program will take care of maximum rebar data, and it directly give the detailing. Bottom, say top X. If we provide the through and through, then it will provide the reinforcement data through and through. So that's why I'm just putting only those area over there where it's required the additional rebar. It is taking a little bit time because of we need to manually model it, and I wanted to show you how these things are modeled. If you want, you can directly take from the existing file also, but it's better I will just show you how we can directly generate it here. Okay, for the bottom, what I will do is only for the rest of the areas I will do, not for the whole areas, so that I can show you how the things are calculated. Okay, now I just come to the next part. Here we are having the setting. This particular setting, it is only for the drawing generation. I will say output option. If you want the Midas CAD or whether you want the AutoCAD. AutoCAD means it will directly generate the AutoCAD drawing. If you say Midas CAD, it will generate the one layout. You can set your drawing by your own way, and then later on you can save as into the AutoCAD drawing. So these are the options are available. So AutoCAD, if you click the program, it directly generate the AutoCAD drawing. But I wanted to show you in the Midas CAD. I just click the Midas CAD and OK. I just save this one. Yeah, say OK. I just say generate AutoCAD drawing. Now in the generation of the AutoCAD drawing, it will ask me the which type of the sheet you want to use. I just say A1 sheet, say OK. Now it is generated on the sheet. If you properly define the general notes or something, the entire thing it will automatically coming here. If you say this one OK, now you can see this type of the general notes you can automatically input. So this option is also available. Now in the plan, if I want the fourth floor or third floor, I just say third floor plan. This is my one plan, 1:200 scale. Okay. Okay. Now this is my first floor plan with my entire thing. If you want, you can hide the data. So many data are there to hide. Then I come to the sections. If I want the particular, I can just say X1 grid, say X1. Say instead of this one, say OK. And I just click here. Now you can see this is the one elevation is also generated at that particular this one. Now my one layout it is generated. Now I come to the member list, beam longitudinal rebar data. I just click here, say OK, and click here. So depending upon your number of the beam data and this one, the program will directly generate the rebar data. Now you can see this is the rebar data I generated. This one, the J3 second floor, 450 by 900 beam, it is required, and it will show that top bar how much, bottom bar, even the reinforcement. This data it is calculated. So according to that, it will calculate. Then second one, column section. Okay, I just use this one. Now here you can see it will generate the section, particularly section, even the stirrups detail, even the all this thing into the one format with the length, total length and the entire thing. So this is the one option for the column, even for the longitudinal girders. because this is this one. So longitudinal girders also you can see in this way, the particular column with the cantilever portion or roof, entire thing. So in this way you can get. Next thing, wall rebar data. It will show into the tabular format about the wall. So according to this method, so for W1 and for W2, first floor to fourth floor thickness and the vertical rebar and the horizontal rebar. Then if I come to the column section, if I open any X1, C1 column and click here, okay, now I just click here. Now you are asking about the one question about the elevation of the column. Now you can see the elevation of the column, the particular elevation with the section, even the splicings, you can see here how the splice and the entire thing it will consider lapping and entire thing. If you define the proper lapping and the length and the entire thing, you can get the proper drawings also. Now if you generate this one, if you just right click here, just say save, if you can directly save into the DWG format. So these are the drawings you can directly generate. Now lastly I will show about the raft. I just say here, say raft, third floor, this one. I first wanted to show you about the top, show representative rebar, click here. Now you can see here, the program will tell you about this particular raft detailing. So this one, additional bar, this is the length of the bar, 10 at 400, it is required at the top and up to this much length. Even it is mentioned about this one. This is for the third floor slab, top X direction, top Y direction. Now you can see the vertical it is showing about the Y. Bottom, this is for the bottom bar, and if you say about this one, only this area it is showing because we have marked only this area. Now in this area only it will show the rebars. So according to that you can generate the flat slab drawing, even the beam, column drawing by using the D shop. And if I come to the model view and if I say tools and the bill of material, just say okay. Now it will open the one Excel sheet. Now in the Excel sheet it is mentioned about each floor, beam, column, brace, slab and wall. What is my concrete? What is my steel values? My formwork value it is mentioned, and in the bottom it is mentioned about the tons also. Now you can see 10.9 ton for this total, this one for slab, wall and these things. Now you can see only for the third floor we are modeling this one, so you can get the particular values. So this is regarding the D shop, and what are the things you can do it in the Midas Gen. The same thing it is implemented here. It is not design any elements or something here. So what are the things you want, you can directly import it from the Midas Gen. So this is regarding the D shop. If you have any doubt about the D shop, so I will explain you. Otherwise you can ask or you can mail us on the tech support @ midasit.com. Anybody want to know about the D shops? Okay. I think it is the drafting tool, so there is no too much of questions regarding the D shop, but the various options are available to use for the D shop. So this is about the little bit just introductory part about the flat slab in the Midas Gen and the D shop, and the little bit about the Design Plus. If you face any difficulty, you can mail us on the tech support @midasit.com. And thanks all of you for attending the webinar. Simultaneously we will do the next webinars also for the rest of the things. So if you require any help, you can mail us, and we will try to solve your problems. And thanks for attending, and we will send you this particular recorded copy also. So thank you all of you for attending the lecture. Okay, have a nice day, and thanks a lot for the attending the lectures. Myself Abhishek from the Midas IT. So if you required any help, you can mail us on our tech support @midasit.com. Thank you so much.